Hi everyone! In this video, I'm going to share with you data representation in computers. In the computer, data is recorded as electronic signals or indicators. Data are actually raw facts. For instance, name of a person, numbers, letters of the alphabet, pictures, video, audio. Those are actually examples of data. Okay, the presence represents by 1 or on, or absence 0 or represented by off of these signals in a specific circuitry. Humans interpret words, pictures, while computers actually interpret only patterns of bits, which is 1 means on in a specific circuitry and 0 means off in a specific circuitry. Let us understand how computer interprets data and information. Okay, consider the ordinary light bulb. At any given time, these are the light bulb, can be either on or off. It can be in only of two possible conditions. It operates in what is termed as binary mode. Bi means to the base 2. The term bit is an abbreviation of binary digit and represents the smallest piece of data. Okay, so this is the binary system. So bi means to the base 2. Here, the first light bulb from the right to left is represented by 1. And here, you can see this light bulb is off, for instance. Next light bulb is represented by 2, meaning these are numbers which are powers of 2. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64, and so on, because computers actually can represent large numbers. Okay, so for instance, this one, the first digit is 1, off, second is off, third is on, and the fourth digit is on. So there are only 2 on digit and 2 off digits. So here we can represent on the first digit, the equivalent is off. So it's off actually is 0 in a specific circuitry. Here, off. The next digit is off again. Here, so it's represented by 0 since it's off. The next digit is 4. Here, it's on. Here, so it is represented by 1 because computers can understand only on and off in a specific circuitry, or it is called binary. Next digit is on. Here, so on is represented by 1 and 0 represented by off. So in this case, the equivalent is, these are the multiplier and these are the equivalent. Okay, so for example, 1 times 0, it's 0. Here, 2 times 0, it's 0. 1 times 4 is 4, and 8 times 1, it's 8. So we will count only the on digit. So since there are only 2 on digit, which is the 4 and the 8. So the equivalent of this one is get the sum only of the on digit. You are actually pressing number 12 in computer. Decimal to binary conversion. Decimal numbers are to the base 10. DC means 10 to the base 10 here, DC. And bi means to the base 2, this one. The rule of decimal to binary conversion is simple. Convert decimal whole numbers from base 10, which is decimal numbers, to the base 10 and to any other base. Divide the number repeatedly by the value of the base to which the number is being converted. Okay, the number is being converted is to the base 2, which is binary. Okay, the division operation is repeated until the quotient is 0, meaning you get the quotient and stop only division if the quotient becomes 0 here. Okay, the remainders written in reverse of the order in which they are obtained from form the new equivalent numeral here. You start here writing from left to right here. Okay, so let us compute this first example. So example 45 in decimal, DC means to the base 10, blank in what is the value in binary. Okay, so these are the numbers we are using from human, and binary means from the computer equivalent. Okay, so 45, divide repeatedly the given here, 45 divided by 2. Okay, you start here. For instance, we are going to divide 45 divided by 2. Okay, so 4 divided by 2 is 2. 2 times 2 is 4. Then subtract, bring down 5. Okay, 5 divided by 2 is 2. And 2 times 2 is 4. So when we subtract 5 minus 4, it's 1. So this is actually the remainder in basic division. Okay? Means you write the remainder here, this one, the remainder, and the quotient here. Okay, so next you copy 22, this one, you copy the 22 and write here on the second, since the rule says that you're going to divide repeatedly. Okay, so this time you divide 22 divided by 2 again. Divided by 2, so that's 2 divided by 2 is 1. 1 times 2 is 2. And 0, bring down 2. 2 divided by 2 is 1. 1 times 2 is 2. So 2 minus 2 is 0. So no remainder. This is the remainder. 0. So you write the remainder here. This is the remainder. And then the quotient here. Okay? And do the same with the next number. So again, you copy the 11 here. Copy, divide repeatedly. Then simply 11 divided by 2, it's 5. So when multiply 5 times 2, it's only 10. So there is a remainder 1. So this is correct. Check. Okay, next you copy the 5 again here. Divided by 2, that's 2. So there is a remainder 1, since 2 times 2, it's only 4. Okay, so next you copy the 2 again here. 2 divided by 2, it's 1. Check. These are the quotient. And next, there is no remainder, 0. So this is correct. Next, you copy the 1 here. 1 divided by 2 is 0. And the remainder is 1. Okay. Do not be confused of the last portion, since all the numbers you are going to convert from decimal to binary is it will end on 1 divided by 2. 0. This time you will stop division, since the rule says that if the quotient, you stop division if the quotient becomes 0. This time the quotient is 0. So you stop division. Okay? This time you write this as from left to right. Here you can actually like this. Write this one. From here you write the 1 here. 1. From left to right, then 0. The next 1. Then 1 here. Then 0. This is actually the sequence when you write from left to right. And the last one is 1. Here. Okay. How will you know that your answer is correct? This time, these are actually powers of 2. I said, you count only the on digit. On represented by 1 and off is 0. So do not count all the values from 0. Okay, you count only the 1. Here, you can see on the table, okay, look at the table here. 1 on the first digit, the equivalent is 1. Okay, next, 0. Do not count the 2. The result is 0 because it's off on a specific circuitry. Next, the next digit is 1 times 4, 4. Next, 1 times 8, 8. The next digit is 0 times 16, it's 0. Next is 1 on. So you count, meaning the value of this is 32. So 1 times 32 is 32. So do not be confused. The first digit is 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. And the next digit, if for example, if you're going to compute large numbers, is 32, 64, 64, 128, 256 times 2, 512 times 2, 1024 times 2, 2048, and so on. For instance, if you're going to convert large numbers, it's the same actually sequence on how to compute, to convert decimal to binary conversion. Okay? Okay, next, let us have another example. For example, 89. Decimal to binary. Okay, so for instance, you're going to compute 89. So, first rule is you're going to divide 89 first here. 89 divided by 2. Okay, so next, 89 divided by 2. Okay, so if you're going to use a calculator, which is not actually recommended during the test, if it's 0.5, it's actually remainder 1. Okay, so 8 divided by 2, it's 4. 4 times 2, it's 8. Bring down 9. 9 divided by 2, it's 4. And 4 times 2, it's 8. Remainder 9 minus 8 is 1. So this is the first remainder. So you write here the first remainder, 1, and the quotient, first quotient is 44. Okay, so next, 44. Divide repeatedly by 2. 2. 44 divided by 2 is 22. Okay, so half of 44 is 22. Okay, then no remainder, 0. Okay, you copy the 22 here. 22, this is the 44. 22 divided by 2. It's 11. 211 is 22, so no remainder. Next, you copy the 11 here. Divided by 2, so it's 5. Okay, 5 times 2, it's 10, so remainder 1. Next, copy the 5. Stop division only if the quotient is 0. 5 divided by 2, it's 2. So, remainder 1. Okay, next, you copy the 2. Divided by 2, it's 1. No remainder, 0. Why sobra? 1 divided by 2. This is the last one. So, always take note that it will end on 1 divided by 2 always. It is equal to 0. Do not be confused. And remainder 1. So, if we're going to write the answer, we will start here from left to right. Or just simply write in this direction. Okay, you start with 1 here from bottom. Next is 0. Next is 1, 1, 0, 0, then the last one, 1. Okay, the first one is here, on. Next is 0. The next is, this is actually 0. 0, and this is 0 actually. 0. Next digit, the fourth digit is 1. Check. Next digit is 1. This is 1 actually. And next is 0. Next is 1. Okay, so in this case, we will write here 32 times 2 is 64, because these are the numbers here. These are powers of 2 or times 2 the number. Okay, so this time we will multiply. One times 1 is 1. Next, 0 times 2. 0 times 2, 0. Next, 0 times 4. This is actually 0. Next, 1 times 8. 8, check. Next, this is 1. So 1 times 16 means this is on. This is 16. Correction. Okay, next, this is 0. So this is 0 times 32. This is actually 0, the value. And next is 64. I mean 64. This is 64. Not 62. 64. Okay. So this time, to check, you count only the on digit. Okay. So this is not for the, this is for the first example. Okay. So you count only the on digit. The first digit is 64. So we are going to total 64. Here, the first on, this one. Next on is 16. This one, 16. The next on digit is 8. 8. Next on digit is 1 here. So 1. Okay, you count only the on digit. You count only the 64 since this is on here. The next on digit is 16. 8. Count only the on digit again. Then the 1. So if this is 89, so our answer is correct. Okay, so we will add 4 plus 6 is 10, plus 8, 18, plus 1, 19. So 9, 19. So carry 1. 1 plus 6 is 7, plus 1 is 8. So this is 89, which is equal to here. So meaning, this is the correct answer. This one. Okay, so that's all how to convert, or how to convert decimal to binary. And this is how computer works. It understands only on and off in a specific circuitry. 1 means on and 0 means off in a specific circuitry, but it can represent all data in computer: numeric, alphanumeric characters, pictures, videos, and audio. Okay, so thank you so much for watching.